In calculating the integral of dx divided by x squared, x to the fourth minus 16, we're going to apply the method of partial fraction. So let us factor out the denominator. Our denominator is x to the fourth minus 16. This can be written as x to the fourth minus 2 to power 4. So in general, if you have something like a squared minus b squared, this can be written as a minus b times a plus b. And if you have something like a to the fourth minus b to the fourth, it is a squared minus b squared times a squared plus b squared from algebra. So let us move this guy down a little bit so we have enough space for the rest of it. So x squared, x to the fourth minus 16, which is x to the fourth minus 2 to power 4, can be written as x squared minus 4 times x squared plus 4. But at the same time, x squared minus 4 can be broken down into x minus 2 times x plus 2, and you're just going to copy down x squared plus 4. So what do we see so far? We see that our denominator, is factored into 3 expressions. 2 distinct linear expressions and 1 quadratic expression. And please note that your quadratic expression cannot be broken down into smaller pieces because the discriminant is negative. So 1 divided by x to power 4 minus 16 can be written as a divided by x minus 2 plus b divided by x plus 2 plus, now we need some more terms, plus EF, EX plus F divided by x squared plus 4. Perfect. So take common denominator on the right-hand side, set the numerators equal to each other. Take the common denominator and then set the numerators equal. So the common denominator is x minus 2 times x plus 2 times x squared plus 4. This is your common denominator. So the numerator on the left-hand side is 1. The numerator on the right-hand side is a times x plus 2 times x squared plus 4 plus b times x minus 2 times x squared plus 4 plus, now you have ex plus f times, so let me just write it in squeezed form, ex plus f times x squared minus 4. So I'm going to just write it in compact form, x squared minus 4. Very good. So let us begin, everybody. Let us distribute this into parentheses. 1 is equal to, so here you have ax plus 2a multiplied by x squared plus 4. So here you have ax times x squared plus 4ax plus 8, not 8, you have, so now we just, yeah, you have 8. So you have 8a, and then plus 2ax squared. So 2ax squared. Very good. So let us move on to the second part. You have bx cubed, or just let me write down everything. B times x squared. Then you have 4bx plus 4bx plus, let's continue this process. Now here you have negative 2bx squared. So let me change this to negative 2bx squared. And then here we have negative 8b, negative 8 and b. And for the last term, here you have the multiplication plus ex cubed. So ex times x squared minus 4ex plus fx squared minus 4f. Perfect. So as you can see, on the left-hand side, you only have a constant. You don't have any x or x squared. What's the meaning of that? It means that you get a combination that are equal to 0. For example, if we rewrite this in nicer form, 1 is equal to ax cubed plus 4ax plus 8a plus 2ax squared plus bx cubed plus 4bx minus 2bx squared minus 8b plus ex cubed minus 4ex plus fx squared minus 4f. So pay attention here. You have some ax cubed or bx cubed or ex cubed, but on the left-hand side, you don't have any x cubed. What's the meaning of that? It means that a plus b plus e must be 0. What about x squared? For the x squared, you have 2ax squared, negative 2bx squared, fx squared. And on the left-hand side, you don't have any x squared. So it means that it is equal to 0. You have 2a minus 2b plus f. It must be equal to 0 as well. What about linear terms? The same for linear terms. 4ax, 4bx, negative 4ex. On the left-hand side, there is no x. It means that the coefficient is equal to 0. So 4a plus 4b minus 4e is also equal to 0. But for the constants themselves, if we take a look at the constants, you have 8a minus 8b minus 4f. It is equal to 1 on the other side. Okay, take a look. What do we have? We have a system of equations, 4 of them with 4 variables, right? So you can take 2 by 2, get rid of unnecessary variables, and then try to solve it. This is a system of linear equations. If you know how to apply matrices, you can use matrices as well. So what I'm going to do, I'm going to look at the terms that has A, B, and F. So I'm going to group these together and see what I can get out of it. So 2A minus 2B plus F is equal to 0. And also I have 8A minus 8B minus 4F equals to 1. So if I multiply the first one by, let's see, by, let's just multiply it by 4, am I right, to get rid of F. And then you can combine A and B. So this guy can be written as 8A minus 8B plus 4F equal to 0. Copy down the second equation, 8A minus 8B minus 4F equals to 1. So now if you add these together, you get 16A minus 16B plus 0 equals to 1. So you find the relation between A and B here. If you can find another relation between A and B, then you're done. So what I'm going to do, I'm going to take, let me use a different color. I'm going to now take these two and get rid of E. So I have a relation between A and B, so I can find these values. So here I get, let's see, A plus B plus E equal to 0. And I also have 4A plus 4B minus 4E equal to 0, which can be written as 4A. If I multiply the first equation by 4, I get 4A plus 4B plus 4E equal to 0. And the second equation stays the same, 4A plus 4B minus 4E equal to 0. So when you add these together, what do we get? You can get rid of E as you get rid of F here. You get 8A plus 8B equal to, and let me see, 0. So what's the meaning of this equation? It means that A equals to negative B. So if you plug this guy in here, you get 16A and B is also negative A plus 16A equals to 1, or 32A is equal to 1, or A is 1 over 32. Okay, A is 1 over 32. What is B then? B is negative 1 over 32. So we found the values for A and B. You can easily calculate E and F now. So since we have the values for A and B, we can calculate E and F. We know that 2A minus 2B plus F is equal to 0, right? So 2 times 32, 1 over 32, minus, this we're going to get plus 2 times 1 over 32 plus F is equal to 0. So you have 1 over 16 plus 1 over 16 plus F is equal to 0. So you have 2 divided by 16, or 1 over 8 plus F is 0. So F is negative 1 over 8. Very good. We found F as well. What about my E? Okay. I have A plus B plus E equal to 0, am I right? This is the equation that I'm seeing here. I found my f. Now for e, a plus b plus e is equal to 0. A plus b plus e is equal to 0. 1 over 32 plus, I'm sorry, 1 minus 1 over 32. Negative 1 over 32 plus e is equal to 0. So e becomes 0. Perfect. So let's go back to our, oh God, this is a very long process, but we learned a lot. So here you go, copy and paste down here for the partial fraction, plug in all the values, get rid of unnecessary lines. So here you have a, which is 1 over 32, and b is equal to negative 1 over 32. My e is equal to 0 and f is negative 1 over 8. So this guy disappears and my f is negative 1 over 8. Perfect. Now let us take the integral. The integral of 1 over x to the 4 minus 16 dx is equal to the integral of 1 over 32 x minus 2 plus negative 1 over 32 x plus 2 minus 1 over 8 divided by x squared plus 4. Perfect. So the first integral is 1 over 32 ln of absolute value of x minus 2. Remember that the integral of du divided by u is equal to ln of absolute value of u plus c. When you take u to be x minus 2, du is just dx. The same for the second integral. Get negative 1 over 32 ln of absolute value of x plus 2. Let's put everything in absolute value. And finally, for this integral, you have negative 1 over 8. Remind yourselves of the integral of du divided by u squared plus a squared. This is equal to 1 over a inverse tangent of u over a plus c. A squared is equal to 4, so a is equal to 2. So you have times 1 over 2 inverse tangent of x divided by 2 plus constant of integration. So this integral, the integral of dx divided by x to the 4th minus 16 can be written as 1 over 32. You can combine these two ln's, ln of absolute value of x minus 2 divided by x plus 2 minus 1 over 16 arctangent or inverse tangent of x divided by 2 plus constant of integration.